This series of videos is a tutorial for the R package statgenstar. In this first video, I'll give you a brief introduction to this package and show you how to prepare data for the analysis. The statgenstar package is a package for analyzing data of plant breeding experiments with options of using different modeling engines. Actually, the package provides 3 different modeling engines, which are SPATS, LME4, and SREMO. And these are existing R packages that perform the analysis of field trials. So to use statgenstar package, we need to first install these 3 packages. We'll use installed packages function to install packages. Okay. This is how we install the packages. And in addition, these packages are allowed to be used for the analysis of different types of experimental designs, including incomplete block design, RCBD, and spatial models with ROCOM design. But note that the spatial models can only be fitted using SPATS and SREMO. Also, I will use 3 field trial datasets as examples throughout this tutorial. So let's get started. Before importing datasets, we need to first load some packages. Okay. And in R, we use the function library to load the packages. The first package we load is called readXL. And this package makes it easy to get data out of Excel and into R. So basically, it is used to read the data which is stored in Excel to R. Okay. And the second one is called dplyr. This one is a data manipulation tool, and I'll show you how to use it later. And the third package is the famous ggplot2, and we'll use it to plot the layout of those experiments. And the next package is called agridat. This one provides a large number of data examples from various types of field trials. And we'll use one of the datasets from it to demonstrate how to perform the analysis for the experiments with alpha lattice design. And the last one is obviously statgenstar. Also, it is often convenient to use the function setwd to set the working directory to the one where we save the data files, so that we don't have to copy and paste this long path every time when we import the data. So let's read the first dataset in. Before doing that, let's first take a look at the original data file in Excel. You can see here we have a bunch of columns such as row positions, column positions, plot IDs, experiments, genotypes, and yield. And we have, I think, more than 3,000 rows. That is 3,000 observations. And let's go back to R to read this dataset in. Since the first dataset is stored in Excel file, so we'll use the function readXLS, which is a function from this package, readXL package. So let's call this dataset data1, and the function is read --line XLS. Sorry, I haven't loaded these packages, so let's do that. Sometimes you'll see these warning messages, but it's fine to just ignore them. And we need to know the name of this file. So let's go back to the folder and get the name of this file. Okay, so we just copy and paste. So if you don't set working directory, then you'll have to put like this whole path here, okay? Because your data files is saved in this directory. But since we have set the working directory, so we don't have to do this. We just put the name of the files here. And recall that we saw that there are some extra row and columns in that data files, and we don't want to get them into R. So to do that, there is an argument in this readXLS function, which is called range. So you just put the range of the row and columns which you want to read them into R. Okay. So let's go to the data file and see the range. Here, the range is from A1 to the last row, which is 3724, and the column is from A to N. So in R, we'll put double quote A1 to N 3723. Okay. And then we run this line to get the data read in. Here, if we click this data 1, we'll see this data set has already been stored in R. Okay. And next, if we want to see the structure of the data, we can use a function called str, str. And we put data 1 here. And let's see the output. Okay. We can see here it gives you the general structure of the dataset. It is a dataset with 3722 rows and 14 columns. And these are the 14 variables. It also provides the types of the variables. For example, here, num means the variable is numeric, and the CHR stands for character. Also, please notice that this block variable is actually our trial variable. And we have 4 different trials. Let's see what are those trials. We can use a function called levels. The levels function gives the levels of a factor. So in order to see the levels, we need to first make the variable as a factor using the factor function. Okay. Factor, we put data 1, and we use a $sign to select the column where we want to see the levels. Okay, this should be levels. And we'll put block variable here. And you can see we have 1, 2, 3, 4 trials. The other way to see the levels is using the unique function. But now we should not transform the variable into a factor. So we just put data 1 $sign block, and again we get 1, 2, 3, 4, but they are numbers instead of characters. So next, let's import the second data set. And let's give it a name, data2. And this data set is a CSV file. So we'll use the function read.csv to read the data set in. And first we'll put the name of this data set here, which is called resolvable ibd.csv. And note that here we need to set the argument header equal to true, so that the function will recognize the first line of this data set, like the first row of this data set, as the names of the variables. Otherwise, it will be imported as a data set with only one variable. Okay? And if we run this line, and you can see here, data 2, which is a data set with 8 variables and 1080 observations. And then we can use the stir function to take a further look at this data set. So here, you can see we have these 8 variables, we have replicates, subblocks, row and column, and trials, and this one is the response variable, is the EO. And let's see how many replicates we have in this data set. We can use a unique function $rep. Here you can see we have 2 replicates. And how many trials do we have? Let's use the levels function to do that. And you can also use a unique function. It's the same. It will give you the same result. And the levels of factor, because this trial function, this trial variable is a numerical variable here, so we need to transform it into a factor. Data 2 trial. So we have 9 different trials, and this is data 2. And finally, let's get the last data set. And as I mentioned before, this data set is a data example from this AgriDate package. And actually, this data set comes from a field experiment that is actually laid out as an AlphaLatex design. So first, let's use the data function to load the data in. Okay? And we just put the name of this data set. This name is this. So actually, we don't need this quote. Load it. And to save it in R, we have to give it a name. So we just call it data 3. And then we just put name of this data set there. Okay. And then you can see here is the data 3. And there is 48 observations and 6 variables. Okay. And we use stir function to take a look at the data set. Okay. So we can see here we have replicates, blocks, row, column, genotypes, and yield. And note that here the replicates, blocks, and the genotypes are already factors. And it gives you the number of levels of these factors. Okay. 3 replicates, 12 blocks, and actually 4 blocks per replicate, and 16 genotypes.